Hi, and welcome back to the second video in my series of videos on exponents. Well, this time we're going to talk about some multiplication applications of exponent rules, okay? Well, the first one that we're going to talk about is the product of a power. Well, what does the product of a power mean? Well, remember in the last video I talked about x to the n, the whole thing being the power, and I talked about this part, or the x being the base, and then the exponent, what the base is raised to, is called the exponent. Okay? Well, the product of a power is basically just that. We know that product means that you're going to deal with multiplication. It's telling you it's the result of multiplying two things. So what are we multiplying? Well, we're multiplying two powers. So the product of a power would be something like x to the n times x to the n. Well, the rule for product of a power would say, basically, if I have two bases that are the same, let's say I have x to the n times x to the n, x and x are both my bases, and those are the same. So because those bases are the same, the product of a power rule tells me to add their exponents in order to get a new power. So the base stays the same, x, and so now that becomes n plus n, right? And so that's x to the 2n. So now I have two of them because I added the two powers. So basically the new power is a result of the addition of both of the exponents. So let's try some practical ones, some that are less, that have less variables in them. Let's say I have 6 to the third times 6 to the fourth. Well, the base 6 will stay the same, and the new exponent, which is now a product of the two powers, is going to be 7. So my new power is 6 to the 7th. And let's say I have x to the 5th times x to the negative 2, which is a negative exponent. Well, I still do the same thing. So now my base x is of a new exponent, so it's going to be 5 plus negative 2. And we know that when we add 5 and negative 2, we get x to the third power, okay? So basically, for the product of a power, you add the two exponents. Now let's look at a power of a power. Well, what does that mean? Well, let's say if x to the n was a power, and now I want to take the power of another power. So basically, the whole x to the n power is now the base of a new exponent, which creates a new power. So let's say we said it was to the m. So I have x to the n, then whatever that power is to the m. Well, you multiply the exponents in this case. So for the power of a power rule, you multiply the exponents, whereas in the product of a power, you added the exponents. Exponents. Okay, so when we multiply the two exponents, it's now going to be x to the n times m. So let's put some numbers in there. Let's say I had 4 to the second power and then raised to the third power. Well, now I have 4 to the sixth power. And if I wanted to evaluate, it would be 4 times 4 times 4 times 4 times 4, 6 times. Okay, so let's say I had x to the fourth power and raise again to the eighth power. Well, now that becomes x to the 32nd power. So I multiply these exponents. So the power of a power, I kind of describe it to if you have a router at home and you want to increase your internet, right? You multiply your internet by installing a router to that router, which will expand your internet, it will multiply it. So basically the power of a power, you multiply the power you multiply a power that's already a power. So just like you multiply the speed of your router, which is already multiplying your signal. Okay, so now we come to the power of a product. And the power of a product is just that. Let's say I have A times B. So that's a product. We're multiplying those two bases together. But then we're going to, after we multiply them, we're going to raise them to a power. So let's say we're raising them to the power of n. Well, in that case, you take the power that's already on them. So if I just have A and B and they don't already have any exponents on them, then A to the 1, B to the 1 is understood to be So now I'm going to multiply or distribute that power to each one of those bases and exponents, okay? So a to the 1 now becomes a to the 1 times n, because I'm applying the exponent outside the brackets n, the new exponent, and then times b to the 1, which it already was, times the new exponent that's being applied to it n. So it's a product of two powers. I'm sorry, it's now a power of a product, excuse me. All right, so we have now a to the n, b to the n. So a times b to the n now becomes a to the n, b to the n. So I'm applying that power to something that we've already taken the product of. Okay, so let's try it with numbers. So I have x to the second, z to the third, and I want to raise that to the fourth power. Okay, so let's try that. I have x to the second. Well, I multiply it just like I did in the power of power rule. So I kind of take the power of the power of a product. I know it can get we're talking about a lot of powers and products, but just remember that you are distributing or multiplying the exponents. So now this one becomes x to the 2 times 4, which is 8, and then z to the 3 times 4, which is 12. So my new product, I now have x to the 8th and z to the 12th. Okay, let's try it again. Let's try it with 2 to the 3rd times 3 to the 2nd. And then I want to raise that to the 2nd power. So let's try that. So basically now I'm going to have 2 to the 3 times 2, which is 6. And then now 3 to the 4th. 3 to the 4th power. Okay, so basically if I take 2 to the 6th, that becomes 64 times 81. 3 to the 4th is 81. And so if I go ahead and multiply that out and find the value of that, that becomes 5,184. All right, so we've looked at product of a power, we've looked at power of a power, and we've looked at power of a product. Okay, so hopefully you can apply these rules and figure out what comes where, when you're looking at simplifying exponents, expressions.